In this video, we're going to look at how to solve a basic equation. Hopefully this is review, but first we're going to look at the definition of an equation. Equation is something that says that two expressions are equal, so it's going to have an equal sign in it. A solution to that is any value of the variable that makes the equation true. So true just means it works. So we want whatever's over here on the left to be exactly the same as whatever's over here on the right. So the first thing we're going to do is make sure that we isolate the variable. That's like the main thing that we're doing here, is getting the variable by itself. To do that, we're going to use inverse operations. The reason is that when we were in elementary school, we were given problems like this, and we had to come up then with the answer. Now we're going to be given problems like this, where we know the answer. We need to work backwards and figure out what we started with. So we've learned about PEMDAS, we've talked about PEMDAS, and when we're given the problem and we have to come up with the answer, we follow PEMDAS. Since now we're working backwards, we need to follow PEMDAS backwards. And that's anytime we need to solve for an unknown value. That means we need to figure out what we started with. So if we see any addition or subtraction, we're going to undo that first. Then we're going to move on to multiplication and division. And then eventually, later in the year, we'll work on getting rid of exponents. And then last, we'll get rid of anything that's in parentheses. So we're just going to do that backwards. And again, so that's why we're using inverse operations. We need to undo things. So inverse of addition is subtraction. And multiplication and division are also inverses of one another. What we need to be careful of, though, is that we make sure to keep the equation balanced. These are equations. They must be equal on both sides. So in order to keep them equal, we need to do the same operation on both sides. Think of a balance. To keep something like a scale balanced, we need to make sure that if we take weights off of this side, we take the same amount of weights off of that side. If we decide to add weights onto another side, we have to add the same amount to the other side to keep this equivalent. And then the last thing I've already touched on, again, we're going to work backwards. So we're going to be following PEMDAS backwards. Remember that addition and subtraction are grouped together. And then we can look at multiplication and division. So we're going to look at a few examples. If you prefer, you can draw a line to the equal sign, just so you remember that's the center of our equation. That separates the two sides. You don't have to do that. That just helps keep it balanced. If x is what you need to get by itself, we're isolating that. We need to move this negative 10. So we need to undo minus 10 by adding 10. And if I add 10 to one side, I must add 10 to the other side. And then it's just a problem like we would complete. So 4 plus 10 is 14. My equals is always stationed right on that line. Negative 10 plus 10 is 0. And all we're left with is x, so the x will drop down. Once we have isolated that variable, that means it's the only thing on one side of our equation, then we're totally done. And so this is your answer. And that means that the value of the variable, x, is 14. If I wanted to check my answer, I can go back and substitute 14 in for x in my original equation. So if I took this original equation, I could replace the x with 14, and I should have a true statement. 14 minus 10 should be the same as 4. So my second example then. Here again, I'm trying to isolate this variable. So this is what I need to undo. And that bar says divided by 3. Well, to undo division, I multiply both sides by 3. If I do it on one side, I have to also do it on the left. It says 3 divided by 3, which equals 1. So this is the same as 1m, or just m. And on this side, I'm taking 1.5 times 3. And 1.5 times 3 is going to be 4.5. Again, that's the value of the variable that makes this equation true. There. 2 more examples. And in C and D, we have more than one step, so we need to make sure that we're following PEMDAS backwards. When two things are touching one another, like the number and the variable, that means they are multiplying. And multiplication has to be saved for after we've gotten rid of addition and subtraction. So because we're working backwards, we're going to start with addition and subtraction. This is what I'm isolating, so this is the side I'm working on. And we have this 6 that we need to get rid of. Since it's a positive 6, we want to take it away. We want to take it to the other side. So 6 minus 6 is 0. And we're going to drop down our negative 2x. And 10 minus 6 is 4. Now the operation we have left is multiplication. We undo multiplication with division. So we're going to divide by negative 2. Because negative 2 goes into itself once, and we're left with 1x, which is just x. And 4 divided by negative 2 is negative 2. And finally, for example D, again, we're going to save all of our multiplication and division until after we have no more addition and subtraction left. So we're going to get rid of this guy first. Okay, we're working on this side because we're isolating that variable. Since the operation says plus 2, I'm going to minus 2 on both sides. 2 minus 2 is 0. I'm left with n minus 7. On this side, we also get 0, but we have to write 0 since there's nothing else there. There's nothing left to carry down, and I cannot leave it blank. Finally, because I'm isolating the n, I need to get rid of this division by 7, and the opposite of dividing by 7 is to multiply by 7. So 7 divided by itself is 1, and I'm left with just n, and 0 times 7 is